So this question was asked in GATE 2016 Electronics and Communication Engineering paper set 3, in which you have given an analog baseband signal which is band limited to 100 Hz and sampled at Nyquist rate. After that, these samples are quantized into 4 message symbols with probability P1, P2, P3 and P4. You have given that P1 equal to P4 and it is 0.125 and P2 equal to P3. Then you need to find out the information rate of this message source in bits per second. So the NPTEL reference for this question is Principle of Communication System Part 2 by Professor Aditya Jagannatham, IIT Kanpur. You can find reference in the lecture number 27, which is Introduction to Entropy. Now, the useful data for this question is, in the information theory, the entropy is the average information of a source. Average information of a source. If the source S is given as S1, S2 till the way to S of I, and the probability of occurrence of these symbols, these samples of this source S as P equal to P1, P2 till the way to Pi, where P1 is the probability of occurrence of S1 and P2 is the probability of occurrence of S2, then you can find the entropy of this source H of S as summation limit as I P of I log base 2 1 over Pi. So this is the entropy of this source S whose samples are S1, S2 to Si, and the probabilities are given as P1, P2 to Pi. Now, in this question, you have given the analog signal is band limited to 100 Hz. That means that your maximum frequency is FM, which is given as 100 Hz. Now, the Nyquist rate is given by Fs, which is equal to 2 times f of m, where f of m is the maximum frequency component. Maximum frequency in the signal. So if this signal, analog signal, is band limited to 100 Hz, then you can find Fs as 2 times 100, which is equal to 200 Hz. Now, after that, the sampled signal is quantized in 4 message symbols. 4 message symbols. And you have given the probability P1 equal to P4 equal to 0.125 and P2 equal to P3. So the by using total probability equal to 1, you can write P1 plus P2 plus P3 plus P4 equal to 1. So by putting P1, P4 as 0.125 and P2 equal to P3, you get 0.25 plus 2 times P2 equal to 1, and you get P2 equal to 0.375, which is also equal to P3. Now, you need to find out the average information, which is your entropy of this source, which is equal to H of S, and this H of S will be given by I equal to 1 to 4 P of I log base 2 1 over Pi. So which can be further expand as P of 1 into log base 2 1 over P1 plus P2 log base 2 1 upon P2 plus P3 log base 2 1 over P3 plus P4 log base 2 1 over P4. So when you put the value of P1 equal to P4 is equal to 0.125 and P2 equal to P3, which you have calculated as 0.375. Then you get H of S as 0.125 times log of 2, 1 over 0.125 plus 0.375 into log base 2, 1 over 0.375 plus 0.375 log 2, 1 over 0.375 plus 0.125 log 2, 1 over 0.125. So by solving this, you will get h of s equal to 1.811. Now, the rate at which the analog signal is sampled is 200 Hz. So the information rate of this analog signal will be given by R times h of s, where R is the sampling rate of the analog signal. So when you multiply 200 with 1.811, then you will get the information rate as 362.255. So the correct answer for this question is 362.255.